So, one of the things we asked you to do over break was create an NTC ID. Make sure that you have created that. If you haven't done so, please do so as soon as possible, meaning by Wednesday, so that we can send over the registry stuff for that. Okay? So, now that we got 9 weeks to go. Okay? Alright? So, the tentative plan is, today and tomorrow we're going to deal with sum and differences of angles. Okay? Wednesday, Heron's formula, okay, which is relatively, we can knock that one out in a day. If it needs to extend into Thursday, then we'll extend it into Thursday. But then Thursday, Friday, we're going to do some half angle and double angle formulas. And then if that needs to extend into Monday, we'll extend that into Monday. But then Monday, second half for sure, Monday and Tuesday, we are going to be studying. Preparation for next week, Wednesday, you're going to take the second half of the NTC final. Okay? Yes, we're taking the NTC final next week, Wednesday. Okay? Because we're done with everything that the trig part of NTC is testing on. Okay? We still have plenty of material that we can go through all of fourth quarter, but we're going to knock that one out. So it's just like first semester, where you had a Wausau School District Scantron final, and you had an NTC short answer part of the final. Okay? You're going to take that NTC short answer part next week, Wednesday. Okay? The Wausau School District Scantron part, we'll take that in May. Okay? So we'll take that in 2 months. Okay? So that's the plan. So prep for that. Also today, you will need your unit circles today. So if you have get out your sheet, your unit circle sheet, because we're going to utilize that all day today. Okay? So, be happy for this moment, because we're back at school. Yay! And it's April 2nd, and there's snow on the ground. A lot of it. With more on the way. A lot of it. And more next week. Yeah, they're talking 2 to 4 next week yet, still. Ridiculous. Yeah? So, you know what warms my insides? Trig. Yeah. So, there's a lot of Hall of Fame things being announced right now. Like college basketball, just because they do it and coincides with their championship weekend, they just announced their Hall of Fame class for 2018. And baseball just announced its Hall of Fame class. And pro football usually does that sometime in the right around Super Bowl time, so a couple months ago. Let's see what else. Your WWE people, they just announced their Hall of Fame. They have a Hall of Fame, by the way. You know. So here's the Hall of Fame for algebraic blunders. Okay? First one is the founding member. Okay? U plus V quantity squared is U squared plus V squared. Yeah, but okay? No, not so much. Okay? Even just by doing 3, 4. Okay? If U is 3 and V is 4, 3 plus 4 is 7. 7 squared is 49. Right? 9 and 16, 3 squared plus 4 squared is 25, not 49. Okay? So right there, that doesn't work. Okay? But I see it 1,000 times every year that one is that. Likewise with the square root of U plus V. Is the square root of U plus the square root of V? No, it's really not. Again, same thing. Square root of 9 plus the square root of 16 is the square root of 25, which is 5, but the square root of 9 plus the square root of 16 is 7. Okay? So again, that doesn't work out. It's this third one that we're going to talk about today. Okay? If I have some function, and I have u plus v, I stick u plus v into that function, that does not mean I stick u into that function, and then I stick v into that function, and I add them together. Okay? What we're going to deal with today is we're going to deal with trig functions and adding and subtracting of angles. Okay? That's what we're going to handle today. So, suppose u and v are angles in radians or degrees, and we'll handle both today and tomorrow. Okay? So then what is the cosine of u minus v? So basically what I'm asking is, if we had the cosine of 60 degrees minus 45 degrees. Well, 60 minus 45 is 15, right? So this is really the cosine of 15 degrees. Now, I could grab a calculator and I could figure out, type in cosine of 15 degrees, cosine of pi over 12. Pi over 12 is 15. And we could get a decimal answer, right? But here's the problem. The problem is that next week, Wednesday, on that NTC final, they're going to say exact. They're not going to say rounded. Okay? Now, for some of you, because I corrected some tests from before break, some of you don't know what the word exact means. Okay? The word exact means no decimals. Okay? So, if I typed in the cosine of 15 degrees, I'd get a decimal. But I don't want a decimal. Okay? I either need it in fraction form, or I need it in radical form. Or, even crazier, I need it in fractional radical form. Okay? So, there's got to be a better way. And I'm actually going to have you refer back to your unit circle sheets now, up here in the upper right-hand corner, numbers 18, 19, and 20. Okay? Here is the formulas. So the first one is the cosine of u plus or minus v. Okay? Is read on your sheet, it says cosine of u times cosine of v minus plus sine of u sine of v. Okay? What that means is, if it's cosine of u plus v, then it's cosine u cosine v minus sine u sine v. Okay? If it's cosine u minus v, then that's cosine u cosine v plus sine u sine v. Okay? So when you're reading these, if it's, you look at what's on top. So the plus here is on the top, which means then that the minus over here is on the top. And your tops have to match up. Okay? Likewise, your bottoms would have to match up. If it's minus here on the left, then it's plus right there on the right. Okay? That's why it's goofy like that. Okay? Plus, minus, minus, plus. Okay? So that's number 18 from our unit circle. Okay? Next one is the sine, then. So sine of the quantity u plus v, or plus minus v, is equal to sine u cosine v plus minus cosine u sine v. Okay? So if it's plus, it's plus. If it's minus, it's minus in that one. Okay? That one is formula number 19. And lastly, we have the tangent formula, which is a little more complicated, just because tangent itself is a little more complicated. And so we have that formula. Tangent of u plus minus v is tangent of u plus minus tangent of v, all divided by 1 minus plus tangent of u times tangent of v. Okay. Now, you're saying to yourself, well, Linz, how are we going to use those? Well, let's get into it. How are we going to use those? I want us to exactly find the value of the cosine of 75 degrees. The problem is, as I look here on my unit circle sheet, 75 degrees is not on there. So I can't find an exact value just by looking at my sheet. I could find a rounded value typing in cosine 75 degrees, okay? But that's not exact. No decimals, and we got to use our unit circle. So, what two things that do show up, bless you, that do show up on our unit circle, add or subtract to get 75 degrees?
30 and 45.
30 and 45. So this could be the cosine of 30 degrees plus 45 degrees. Are those my only choices? What else? I know I threw a monkey wrench in it, didn't I? What else? Well, what's another option? What do you got? 60 and 15. 60 and 15 will work, but 15's not on my unit circle. So I can't use that one. But that would work if I had 15. Yeah. Something else that adds or subtracts to 75 degrees.
120 minus 45.
120 minus 45 would work there too. Okay? What about 135 minus 60? Right? Those would all work, right? What about, I have a think here now, 120 plus 315? Would that work? Would it work? Yeah. Because really, 315 is negative 45 degrees, right? So 120 minus 45 degrees is 75 degrees. So there's a lot of options out there for you, okay? Do you have to go with 30 and 45? No, okay? Mathematically wise, your answer will be the same, okay? Visually, your answer might look different if you use different angles. But mathematically, they will be the same. Okay? Right? So, we're dealing with cosine plus. So that's going to be the cosine of 30 degrees times the cosine of 45 degrees. Then it's minus, because it's plus, we're adding the angles, minus the sine of 30 degrees times the cosine, minus the sine there, minus the sine of 45 degrees. Okay? So, what is the cosine of 30 degrees? Square root of 3 over 2. What is the cosine of 45 degrees? Square root of 2 over 2. What is the sine of 30 degrees? 1/2. What is the sine of 45 degrees? Square root of 2 over 2. Not a fan of my 45 there. Okay? Now we got to take a step back, and we've got to go to multiplying fractions way back in 4th or 5th grade. Okay? So what is the square root of 3 over, or how do I multiply fractions? Change the question halfway through. How do I multiply fractions? So straight across? Yep, we're multiplying straight across. So root 3 over 2 times root 2 over 2. Square root of 6 over 4. Can I simplify the square root of 6 over 4? Yes or no? No, because the 6 is inside the radical. Okay? 1/2 times the square root of 2 over 2. Square root of 2 over 4. Can I do anything with the square root of 6 over 4 minus the square root of 2 over 4? What can I do? Square root of 4. So the square root of 4 is 2 over 4, so it's 1/2. Do we agree with the final answer here being 1/2? Do we agree with that? Yeah? Unit circle-wise, so 75 degrees, is up here, right? So 1/2 is over here. So do you agree now with 1/2? I don't agree with 1/2. Okay? Square root of 6 minus the square root of 2. Can I do anything with that? Can I do anything with that numerator? Nope, can't do anything. So this is the cosine of 75 degrees. Okay. What I would like you to do now is I would like you to find me the sine of 15 degrees. Sine of 15 degrees, what do we use? Did everybody use 45 and 30? No? What'd you go with them? 60 and 45? Everybody use one of those two? Anybody get all funky? 135 minus 120? 30 plus? Oh, no, it'd be negative 10, so it'd be 45 plus negative 30. So 45 and 330. Is that what you did? Yeah. Right? Again, no matter which angles you chose, okay, as long as when you add them or you subtract them, you end up with 15 degrees, you're good. Okay, you're good to go. Okay? It may visually look a little different, but mathematically, it ends up being the same. So, we are in a sine one. I'm going to do my blue one here. Okay? So, the sine of 45 degrees minus 30 degrees is going to be the sine of 45 degrees times the cosine of 30 degrees minus the cosine of 45 degrees times the sine of 30 degrees. Okay. Sine of 45 degrees is the square root of 2 over 2. Cosine at 30 degrees is the square root of 3 over 2. Cosine at 45 is the square root of 2 over 2. Sine at 30 is 1/2. That gives me the square root of 6 over 4 minus the square root of 2 over 4. So the sine here of 15 degrees is the square root of 6 minus the square root of 2 all over 4. Mathematically, we all should have gotten that. Okay? You might have gotten negative square root of 2 plus the square root of 6 all over 4. But that mathematically is the same. Okay? Just when you have all the answers, what do I go and do? I go and I change the question. Huh? So now we're in radians. I need two angles on my unit circle that add up to be, or subtract to be, 5 pi over 12. Okay? So, really, I need something that adds to be 5. This number right here is kind of the important number. So what two numbers add up to be 5, or subtract to be 5 for that matter? 2 and 3, okay? So 2 and 3 would be, so that would be 2 pi over 3, oops, excuse me, not 2 pi over 3, 2 pi over 12 plus 3 pi over 12. Bless you. Those add up to be 5 pi over 12. Do we all agree with that? Okay? Now, really, 2 pi over 12 is pi over 6. And really, 3 pi over 12 is pi over 4. Are both of those on the unit circle? Yeah, so that's good. Okay, so that one would work. Let's find another one. What other two numbers add up to be 4, or add up to be 5? Four and 1, right? Okay, so 4 pi over 12 plus pi over 12, right? This one gets me pi over 3, right? But that one is not on the unit circle. So do I like the purple one? No. Okay? Let's find a difference. What would a difference one be? So now I want to subtract. Okay? What do you got? 10 and 5? Okay? So 10 minus 5, she say. The problem here is that is 5 pi over 6. That's on my unit circle, right? But 5 pi over 12 isn't. Okay? So that one doesn't work. What do you got? 9 and 4? Okay? Because this one is 3 pi over 4, and this one is pi over 3. Right? What about 20 pi over 12 and 15 pi over 12? and we subtract. Does that work? (20 pi over 12 is what? 5 pi over 3? That's on my unit circle. 15 pi over 12 is 5 pi over 4? Yeah, that one works too. Okay? So again, however you do it works for me. So let's go with, this is the sine of 2 pi over 12 plus 3 pi over 12. So this is really the sine of pi over 6 plus pi over 4. Okay? So the sine at that one is going to be so that's going to be the sine of pi over 6 times the cosine of pi over 4 plus the cosine pi over 6 sine of pi over 4. Sine at pi over 6 is 1/2. Cosine at pi over 4 is the square root of 2 over 2. Cosine at pi over 6 is the square root of 3 over 2. Sine at pi over 4 is the square root of 2 over 2. So that's going to be square root 2 over 4. Square root 6 over 4. So that gives me, oops, did it again. Got slow. Yeah, buddy? I think that's a good ending spot for today.